Christian, before we dive into this WebDriver V9 release party, what can people expect today?
We're going to talk about the new features. We're going to talk about breaking changes. We're going to talk about what it's all about WebDriver BiDi and what's upcoming next.
And payment for contributing.
And yeah, how the project develops itself and how you can be a part of it.
We love it. We love it. And you're getting it live? You're good? Sweet.
Audio as well?
The audio is coming in, yeah.
Awesome.
Woohoo!
All right.
With that said,
I think we can get started, huh?
let's do it.
All right. Hello, everyone. Thank you for coming. It's awesome to, I remember, Tristan mentioned that before, that we already been doing this since version 5, where we had a release party, and it's cool to come back to Sauce Labs for version 9 and potentially version 10, and who knows how many more versions we will get. Today we want to go over the release, talk a little bit about the project state of the art, or where the project is right now, where it's going. Talk about WebDriver BiDi. As you might heard, like the protocol finds now adoption across all the browsers, and it's important to understand what WebDriver BiDi is, so we can better understand why we choose the features that we choose for version 9. We're going to obviously talk about the new features that come with WebDriver 9 and the BiDi protocol. We will talk about some breaking changes and what's coming next. Starting with the project state of WebdriverIO. So the project started in 2012 when Camilo Tapia, a guy from Sweden, first released the project on GitHub. It was one of the first projects to allow browser automation, and so I had a university class where I had to automate a browser, and so I started to use and work with WebdriverIO. Back in the day, it was called WebDriver.js, and I think that's when I started my journey contributing to the project, and it's been 12 years now, almost, so quite some time. We then, at some point, renamed ourselves from WebDriver.js to WebdriverIO for various reasons. We joined the JS Foundation because we wanted to be, not owned. I didn't want to own the project. I wanted to have the project be owned by a foundation, so I get a lot of legal help and marketing help and everything that comes with being a part of the foundation. So that has been great. We were the first adopter, or the WebDriver project has been the first adopter for the WebDriver protocol that got adopted, or that kind of became a recommendation standard in 2018, and then 2019 the JS Foundation merged with the OpenJS Foundation. We kind of enhanced our governance model a little bit. We then had 2 rewrites. We rewrote the project in TypeScript. So with, I think, version 5 or version 6, we had to basically touch every file. And the same for version 7, where we rewrote the project from CJS to ESM. So that was a whole effort. Luckily, this time, version 9 didn't require us to rewrite a lot of files, but it was still a lot of code that we touched. Starting this year, 2024, we established a contributor stipend program that allowed us to pay back to maintainers, and essentially pay back to maintainers, essentially saying everyone who makes a contribution to the project gets money back for their work. So that has been working great, and I have some numbers in the slide later. And today we're celebrating version 9 release. So if you look at WebdriverIO in numbers, we have about 1.5 million weekly downloads. We have about 9,000 stars on GitHub. We have around $4,600 monthly funding that we use to pay contributors, maintainers, and things like travel cost from maintainers to conferences, things like that, and also to get stickers and marketing related things. We have about 3,000 unique daily visitors on the website, about 2,000 Discord members, a total of 591 contributors, unique contributors, which I think is pretty awesome. We have 68 project members, and about 45 plus test runner plugins. Since I talked about the contributor stipend program, this wouldn't be possible with our sponsors, namely Source Labs, Browser Stack. We have our gold sponsors, World4Me. Silver sponsors are Lambda Test and Testing Bot, and our bronze sponsors are ESLint, the ESLint project. So without them, we couldn't, sponsor the project as we do right now. We couldn't, pay the contributors back. And I think this has become something very amazing, where we can say, okay, we want to, everyone who makes a contribution to the project gets money back, and every pull request we pay out between like $15 to like $100, $200, depending on the size of the pull request and the complexity. Every person who reviews a pull request is responsible for attaching a number to the face number, the value number for what would be reimbursable. So far, we're able to give out $1,500 since we started the program to 25 individual contributors, which I want to definitely increase. We have much more money for third-party or like outside contributors to give out. So whoever is on the stream or whoever here wants to make a contribution, we have a lot of money to give out to people that want to contribute. And then if you have like contributed 10, 20 pull requests and you become part of the project team, you can earn up to like $80 an hour if you're part of the steering committee team, or $50 an hour if you're if you're a normal project member. That usually doesn't really stay up high. Like, we work much more than the money we have, obviously. So it's going to be less than that, but it's still like a significant number that you can get for contributing to the project. And I want to emphasize that we literally pay out to every single contributor. That means no matter if you do a code contribution, no matter if you do help us in our documentation, no matter if you help us translating our documentation to different languages, we pay out everything, and we want to reimburse everyone who spends time working on the project. Let's get a little bit more technical. Everyone is talking about WebDriver BiDi. It's the new protocol that browsers now these days adopt to allow us automation frameworks to do better introspection of the browser and application. If you heard recently, Puppeteer has adopted it and now supports WebDriver BiDi for Firefox and Chrome, which is amazing. I'm fairly certain that there will be more tools that will adopt the new protocol, and I'm very stoked that WebdriverIO is on the forefront of embedding this protocol into their features. But before we get into BiDi, let's talk a little bit about how what's so great about BiDi. If you think about the WebDriver protocol, it used to be the idea of the WebDriver protocol is great because it allows you to say, I want to automate an operation on the browser, let's say going to a website or clicking on the button. And for that operation, I have someone who can translate that idea of that command to the browser. And so I have a translator essentially for every browser, and I can say, hey, go to my test page, and then I can send this translator to the browser wherever that browser exists on the in the cloud or locally on your machine, and have that translator give that command to the people working in the factory / in the browser and execute that. So that works great. However, it comes with some how would I say that? It comes with some side effects, which means that if your browser is far away from where your tests are executing, then unfortunately, your command may take longer than if you run it locally. So that's a problem. That's why many people say, okay, Selenium is slow, because if you would run, for instance, a command on Source Labs where you would have to go through the whole internet, a command may take 100 milliseconds, versus if you run it locally, it's much faster. However, the good thing about the WebDriver protocol is that you can just scale this very nicely. You can say, you can have not one translator, you can have 100 translators that just do the same thing, go to 100 different browsers. And so if someone comes with an argument saying Selenium is slow, I can say, oh, we have a little break. Okay.
I think that you're going to have to condense everything.
Condense.
You're only 11 minutes in, but I'm hearing from people that didn't hear you. So can you do me a huge solid favor?
Okay.
Give a quick intro, and then also let everyone know that about this project, and then dive in. But I think, Boo, on your side, you are not streaming. That's what I'm getting from the comments.
Let me just check the stream. Let me just see what.
For everyone who's watching this recording, we so appreciate you all. You were streaming on some platforms, but not others. That's okay. That's okay. Can you do, for everyone who's watching live, we love you. Thank you so much for being open source contributors. We are wearing these fun outfits because we are thrilled about y'all being here today. We might have had a quick technical glitch live. That is totally good. If you are watching this stream live, y'all, please, when we get to the Q&A, drop your questions in the LinkedIn Live event, and you will be entered to win some amazing swag. That said, for anyone who is now watching live, we are going to just do a quick little highlight reel. Does that work? Yeah, quick. And then we're going to dive into it.
Okay.
But again, let's show them some code. I love all of this, okay? So, again, y'all, Christian Broman over here. Love this leader so much.
Oh.
And there you go, friend.
I think I have it.
You got it?
Unmute.
So let's start it one more time from the top. Keep it high level and then dive into the code. We love you. All right, y'all. You're the best.
So we start from the beginning?
Yes, but very fast.
Okay, no problem. Let's just start again. Let's sing for everyone who just comes in the room. Yeah, so welcome everyone. Welcome to the WebdriverIO release party. So what we want to do today is essentially, is the audio not good?
Keep on going.
Okay.
People in the comments say otherwise. I think you're good.
What we want to do today is go through the project state of the art of WebdriverIO. We talk a little bit about WebDriver versus WebDriver BiDi. We look into the new features that are now possible thanks to the thanks to the adoption of BiDi. We look at some breaking changes and what's next in the project. A little bit history. WebDriverIO started in 2012, where a guy called Camille Tapio started a JavaScript project to automate the browser. That was way before Selenium even was a thing. WebDriverIO, back then it was called WebdriverJS. I had a university program where I had to use the project to run tests on the browser, and so I started contributing to the project because I thought I needed some features that weren't there. Since then I started contributing to the project and run through, had a chance to learn a lot about different kinds of technologies and different kinds of problems, and most of all, a lot of fun. 2014, we named the project from WebdriverJS to WebdriverIO due to various reasons, but WebdriverIO was, I think, the better project name overall. 2017, we then joined, as we grow and grow further, we then joined the JS Foundation that later migrated into the OpenJS Foundation, which we are still part of. As a form of we get a lot of support from them, not only legally, but also through marketing and other resources. 2018, we were the first project. We were the first project that were adopting the WebDriver protocol. And then we had, with version 6 and 7, two big rewrites. The one was rewrite in TypeScript. The other one was rewriting the project from CommonJS to ESM. And since this year, we started a contributor stipend program, which allows us to pay back every contributor that contributes to the project in all kinds of shapes or form. And today we want to celebrate the V9 release. if we look at some numbers, WebdriverIO has about 1.5 million weekly downloads. We have about 8.9 thousand GitHub stars. We have a budget of $4,600 a month that we use to pay back contributors, to pay back travel costs for contributors, and marketing materials. We have about 2.8 unique daily website visitors, 2,000 Discord members, a total of 591 unique total contributors to the project, which is awesome. Project members, 68, and 45 test runners. So we have a large ecosystem of different projects and different plugins that help you to do different things. All these like work that we can do on the project wouldn't be possible without our sponsors, especially our premium sponsors, Sauce Labs and Browser Stack. They help us out, have the funding to pay back our contributors. We have Route4Me as a gold sponsors, our silver sponsors, Lambda Test and Testing Bot, and lastly our bronze sponsors, ESLint. And they allow us to essentially pay back every person who makes a pull request to the project and helps the project to further grow, to fix bugs, and to create new features. We have currently paid out about 1,500 since the start of the program to 25 individual contributors, which I would love to see much more. Like, we have much more money in the pocket to pay more people out that are not part of the team. So if people on the stream or here in the room, if you want to contribute, you literally can earn money in your free time. If you were part of the team, you can earn up to $80 a month, an hour, or $50 an hour if you're a project member. And we pay out to all contributors, not only the people that contribute code, but also people that want to help us on the design of the website, on the documentation, on making videos or educational content, on marketing materials, everything that helps the project grow and become bigger. We want to pay out that effort. Okay, let's talk about WebDriver BiDi, which has been a big name and has been around on social media a lot recently, as more browsers now have adopted it. But before we want to understand BiDi, we have to get what the WebDriver protocol is. The WebDriver protocol essentially allowed Selenium back in the days to bring what they have defined as a JSON wire protocol as a standard to all browsers. So when Selenium started, they created this protocol that was implemented by an open source community, and then Simon Stewart, the creator of Selenium, went to the W3C and wanted to standardize so that every click is essentially the same in all browsers, and we can automate the browsers in the same way, and all of them without having hacky patches or something like that. The WebDriver protocol, the idea is great. You have a client that wants to automate a remote interface that can not only be a browser, that can be a mobile device, that can be a TV, that can be literally anything. And you give them a command saying, go on this website. And the WebDriver protocol essentially defines an interface that has these commands defined. For visiting an URL, there's a specific set of instructions that a browser needs to execute to fulfill this command. And for the WebDriver protocol to work, you have a translator, which is a browser driver, that then can say, OK, I will go to the browser and will tell the browser what to do, and then I will come back and give you the results. And while a single command may be slow, the great thing about the WebDriver protocol is that you can endlessly scale that. So I could run 1,000 tests in parallel at Sauce Labs and have like 1,000 tests run within 5 or 10 seconds. So if someone comes with the argument that Selenium is slow, that's only true on a single command. But as a whole test suite, you can run it as fast as the resources that you have provide you. And essentially what WebDriver is you have a client like WebdriverIO, a browser driver that translates the WebdriverIO or the WebDriver command into a browser command. And then you have a package, since the WebDriver protocol is based on HTTP, so you can run it on all languages. The package contains some information about the command and the element that you want to interact with. It's fragile because the package can get lost on the internet, but essentially you send it to the browser driver, and the browser driver then sends multiple packages to the browser, depending on which browser you're using. For Chrome, the browser driver would use the Chrome DevTools protocol to then talk to the browser and tell them how to execute the command. And then the driver sends back the response with the result of the command. Now, the cool part about BiDi is when you think about this translator that goes from the client to the factory and then comes back with the result, BiDi gives you kind of like superpowers now. It allows you to essentially just control everything. It allows you to not only control one part of the browser, it allows you to observe everything that's going on from the network level to the console level to what's happening in the DOM tree. The possibilities are almost endless, and that's what makes it so powerful. So the idea is still the same. With WebDriver BiDi, you still have a client, you still have a driver, and you have network packages that you send along. But this time, it's TCP messages. It's WebDriver BiDi is an event-driven protocol, so you're sending little events to the browser driver. And this can not only be one command, this can be multiple commands at the same time. And you can also listen on events that are happening in the browser. So WebdriverIO now constantly communicates with the driver, and the driver also constantly communicates with the browser. And so there's constant communication happening. So that allows us now to build a whole set of new features to the project that we wouldn't be able to do before. So let's dive into some of the features that we can do. One of the first ones that I feel like personally I'm most excited about is being able to automatically peers web components. More and more application move to web components, and the difficult part.
I want to make sure that people can see your screen.
Oh, should I share my screen?
You should share your screen.
Okay.
For everyone on the live stream, we love you so much, and thank you so much for being a part of this amazing community while we're doing this. Yes. Yes, yes, yes. Yes. And then Dave, can you quick check? We're going to make sure everyone is seeing it. If y'all can see this stream live. Yeah, I think that's good. Love it. I have to make sure everyone can see what you're saying. Let me see. Boo, 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 boo. Hold, please. While we're doing all of this, y'all, I want to make sure that you all are dropping in your questions about this exciting release. Yes. And when you drop your questions in for a release, you're going to be entered in for a chance to win some major stuff. Okay.
I think you have to make my screen the main screen on the StreamYard.
Let's check in here.
This one. All right.
We got it? Woo! Just to make sure everyone saw everything. Okay, good.
Awesome.
Back to you, dear reader. Love open source.
So yeah, one of the first features is auto-piercing shadow DOM. What's usually difficult if you automate on an application that uses a lot of shadow DOMs is that you cannot directly query an element within the shadow root, because the shadow root, as defined, encapsulates an element and the elements inside of it. So it's very hard to just query an element within the shadow root. Through WebDriver, there are commands that are out there, but if you take this example, we can query a div and we can query our custom component, but we cannot query anything that's inside of it. So that makes it a little bit difficult. There have been commands like the shadow $ command that would allow us to jump into the shadow root. That was nice, but also kind of still cumbersome because you had to know which shadow roots you want to go into. So if you have, and especially if you change the structure of the DOM where the shadow roots change, then this approach will probably also not work for you reliably, at least anymore. Now with WebDriver version 9, we rebuilt our locator engine and now allow to make element lookups across all shadow roots at the same time. So when you query a button, like the click me button down here, what WebDriver will now do, thanks to BiDi, is to make a lookup on all shadow roots at the same time. And we will also check which shadow roots are being registered on the page and kind of like create a virtual shadow root DOM in memory so that we know how the application is structured and can go from there. And we can just show that in like a little demo that I have here. We have a little Ionic application here. It's a calendar app. And as you can see, make it a little bit bigger. So as you can see here, we have an application that has one shadow root for the whole content, and we have one shadow root for the date picker, and we have a bunch of little shadow roots for icons and little buttons that you have here. It would be very difficult to go from one shadow root into another and then into another. That would it would require you to understand how the DOM and website is structured to then build your queries and create a chain of element lookups for to make this work. So for WebdriverIO now, to get this working, all we need to do is just query the element directly using any of the selectors that we have available. So there's no need for you anymore to know or understand how the website is structured, what kind of shadow roots exist. All you need to do is to find the element you want to interact with and build the selector that allows you to query it. And yes, I have some pauses in here, and that's just because there are some elements or like animations that need to be awaited so that the whole test script runs reliable. But I think it's very nice that you can just like run your commands and then directly interact with the elements rather than have to figure out how the shadow root works and how Shadow DOM works. Another problem with testing web components, especially if you want to do snapshot testing, is that you don't really get what's inside the web component. Since, again, the shadow root is encapsulated, the browser doesn't give you immediately access to what's within the shadow root. With version 9 now, this is actually possible. Since we do the cross shadow root lookups, we get the HTML from all the shadow roots that you want to look into, and we create a declarative shadow DOM string for you that you can then use to match snapshots. Another feature that we have is we enhance the URL command for new options that you can use to better open resources. So in version 8 and before, we had a simple command that only would take a string to the website that you want to open or the application that we want to open. Now with version 9 and BiDi, we can now inject headers into the request. So this is very useful if you want to set a session cookie to authenticate your user, or if you want to set any other kinds of cookies. This will make it very easy to do that. Another way of using those cookies is also to set a header for authorization. And to make this easy for basic authentication, we provided an option called auth, where you can pass in a username and a password, and WebdriverIO will create a basic auth header, and we'll send this along. So it's essentially the same as this one, but it's an easier interface. Sorry. And one last feature for the URL command is now an onBeforeLoad hook that enables you to just run any arbitrary JavaScript before your application actually loads. That allows you to modify the environment of the browser, to override web APIs, for instance, to override web APIs and to override classes of globals that are available, override globals as well. So there's a bunch of cool features that you can do with it. Here's one example. You can override the getBattery function of the navigator object to tell the browser that it should always respond with the same value. And so then you can go to this demo page, and it will show up that your battery is only 50% charged, because you have set it this way in the before script. Next feature is the object serialization. Something that has been difficult in WebDriver was serializing certain objects like infinity, maps, or sets. These primitives are now serializable through the BiDi protocol. So if you pass in a map or a set into the execute method, you will get that map or set in the browser as well. So WebdriverIO takes care of deserializing and serializing these objects for you so that you can use them. And it doesn't even make this way it makes it really easy for us to build better features on top of what we have already. So you can see here in version 8, if you would pass in an infinity object, you would, if you would check if that is infinity, you would get a false. A map would not be serializable, so we would return null. And if you would want to check or use a method of a set object, you would get an error because that set object would not have been serialized as a set object. This now all works in version 9. Next feature is the set viewport command. This has been possible before in WebdriverIO version 8 with the set window size. But the problem with set window size is that you cannot really set the windows of any application to a certain size. So for browsers on Mac, for instance, it would not allow you to set it down to less than 500 pixels. So unfortunately, the images don't show up. But essentially, what's now possible is to actually set the viewport size. And what happens here is that the browser stays the same. The browser window stays in the same size, but it renders the application now in an actual smaller viewport, which allows you to emulate mobile devices like an iPhone to do like some simple sanity checks to see if your application is responsive. And you can also pass in a device pixel ratio to actually like come close to how a mobile device emulates your application. However, that said, this really should not replace your mobile tests. So if your application is served for mobile as well, we would recommend to use WebdriverIO and Appium to actually run these tests on an actual mobile device. So since setting these viewports is nice, and every device has different like viewport dimensions and device pixel ratio values, we enhanced the emulate command with a new device scope that would allow you to just pass in the name of the device, like an iPhone 15. And WebdriverIO has a library of different values for different devices, and it would set the viewport and the device pixel ratio accordingly for you. The next feature is the add init script. The add init script is similar to the on before load command in URL. It allows you to inject a script into the website, which will be invoked whenever you open a website. So it's not only for the page load that you're doing, it's for essentially all page loads in your sessions, unless you're removing this script again. But what this allows you is essentially to set your stage for your application, to override certain things, but also to register listeners to create a mutation observer, for instance, to listen when certain changes happen in the document. And what WebDriver provides here is an emit function that essentially allows you to call back and send back these values back to your test and to your Node.js environment. So if you can call the init script command, you pass in the callback, which is a function that is being run in the browser. And whatever you do in there, you can use the emit command to send back the value to the Node.js script. And in the Node.js script, you can, when you get back the script object from the add init script, you can register a listener on it called data. And the data event listener receives the data whenever you call emit in the browser. And if you want to clean up your init script, you can call the remove function on it. So again, this allows you to, actually allows you like endless possibilities. Like it allows you to override browser globals, to register observers and event handlers, and send back information in the browser that you need for your test. Something that we use, one of the features that we built on top of that is actually fake timers, something that exists in other frameworks already, but is now possible in WebDriver-based frameworks as well. Fake timers allow you to set the time in the browser to whatever time you want to. So if you have a feature that is only allowed when it's Christmas, then you can set the time for Christmas, and you can validate that your application now shows the content that is important for Christmas. So you pass in a date object with the specific date that you want to set the time to. And then what also happens is that you have the power to say whenever, like when you want to enhance the time. So it would, if you set the time, it will not continue to run unless you call the tick command, which allows you to advance the time to whatever milliseconds you prefer to. And lastly, you can, like any emulate script, you can remove that behavior at any given point in time. But as a summary, you can, emulate a certain time in the browser that will continue to be or remain that time until you change it through the through the tick command. So you can say clock await clock.tick, and then you can advance the time by 1 second. And then later on, you can remove the script if you want to go back to the original time. Another feature we added is the automatic dialog handling. Something that has been very annoying for users is when you have these alerts that are popping up randomly. With WebdriverIO version 9 now, we automatically dismiss these alerts because we get an event from the browser whenever these happen. Unless you register an event listener on it called dialog, which gives you a dialog object that allows you to interact with the dialog, to dismiss it, to accept it, to get the message. But if you don't, if you don't create that listener, WebdriverIO would just dismiss the dialog automatically because you're not interested in whatever behavior is behind it. So this will definitely make your test more stable if you have encountered those kind of behaviors before. Coming from the features to some of the breaking changes. For once, we had to tweak a little bit how WebdriverIO element objects work. Before, you could just query an element with an await before, and then access its properties, like the selector, the element ID, and so on. That was a problem because all IDEs were thinking that the WebdriverIO object is a promise. And so if you would chain these objects, if you would query an element and then would have a nested query on that element, it would create some weird behavior where it would await both calls, and it's just a bad developer experience. So we had to remove the property of a WebdriverIO element as being a promise. So you get this element now through the getElement and getElements commands. And so that's just for if you use TypeScript, really. So if you don't use TypeScript, that doesn't really matter to you that much. We removed a bunch of matches that we used before. If you have been using the, I don't know, to have text containing or to have attribute containing matches in WebdriverIO, these are gone now in favor of asymmetric matches that have been built in our expect library before. And so we want to keep our interfaces lean, and we decided to get rid of them in favor of the functionality that's already built in. We have removed the JSON wire protocol commands because we don't believe that anyone is using that protocol anymore, which has been the protocol that was before WebDriver. We have removed the DevTools and DevTools service packages. There's no need really to use the DevTools automation protocol in WebDriver anymore because WebDriver can set up the browser driver for you. So there's no really need for that. There was no real need for that anymore, and it was more to maintain for us, honestly. We also got rid of the DevTools service because if people want to interact with the DevTools protocol, they have a getPuppeteer function that would give them a Puppeteer instance, and Puppeteer is a much better maintained interface to interact with various of CDP Chrome DevTools protocol interfaces. We also got rid of Babel and the autocompile ops, as we have integrated a new TypeScript compiler that makes it just much more easier to run your tests in TypeScript. And since we have deprecated Node.js 16, we were able to now upgrade our request library and use the native fetch instead of the request library we used before. So we removed some dependencies. We got a little bit more lean and a little bit more performant. Speaking of more features, outside of the version 9 release, we also made some changes to our visual service, which now supports storybook testing. So if you have a storybook project, you can essentially just point WebdriverIO to your storybook project, and it can run your test in parallel, up to like 10 or 20 parallel session, and can test 200 components within 10 seconds or more. As you can see in this demo, we use the British government style design system as a guinea pig, and so it created 250 screenshots for us within just 10 seconds. So it allows you to really effectively test your storybook components and make sure that they work across all devices and browsers. So what's next? After almost maybe 12, 13 years of development, is the project done yet? Probably no. I would say we just started, especially with the new BiDi protocol and the new features that we have available. There's so many stuff that we can now add to the project, catch up with features that haven't been possible before, but other people like in other projects. So we're just getting started to build more and more features on top of the project, and we invite everyone to join us on that. We will probably in the next couple of months or weeks, we'll do some more improvements on existing features, like the component testing part, where thanks to WebdriverIO BiDi, we can do a lot of more improvements to make component testing more effective and more performant. We will continue to work on our existing roadmaps items. One of them is a new UI mode, similar to what you see in Cypress or in Playwright. We started to work on an application that allows you to debug your test in real time, to have time travel capabilities, things like that, to do breakpoints, and really have a better ability to write tests, author tests, and debug tests. So that's a huge project, and it's definitely something that I personally cannot do myself alone, nor the other people in the project. So if people come along and want to help us, that would be amazing. And yeah, we're calling out to everyone who's on the stream and everyone here who wants to help us work on the project and learn technologies through it. I think that can be an awesome opportunity to do so. And yeah, so join us on Discord. Our maintainer team is probably always there to help out. If you're looking for things on task to work on, you can join us there, ask questions. And also, if you have questions just using WebdriverIO, you can join us there. With that said, thank you so much for listening, and I'm taking on questions.
Woo! For everyone in the audience and everyone live, y'all, can we get a round of applause wherever you are in the world watching? This man, we so appreciate you. So appreciate you. And honestly, we did a vibe and an event for the V5, and it would not be Oprah and giving gifts if we did not continue this moment. So y'all, we're gonna announce some giveaways tomorrow, so please drop your questions in. I understand there are multiple ways that you are enjoying this informational content, but if you can go to the LinkedIn Sauce Labs live event, that's our best way to track your questions. That said, tomorrow, expect some winners. We've got amazing new swag, and also, I love this man, so these are stupid. Ignore us. Just ignore us. But that said, friend, we are going to go into a few Q&A questions here, okay? One of them is from Luigi, and they ask, are there any breaking changes or deprecations in WebdriverIO that could affect existing test suites?
Yes. So I had a slide on that. Let me just find that.
That was earlier on in our conversation. So, Luigi, that was a great question. Thank you.
We have some breaking changes. I can go over them again. Accessing elements is a little bit different these days. If you use TypeScript, you have to use the getElement command to access the selector properly. That we did because we wanted to make the developer experience easier if you chain multiple element commands with each other. Then we removed the whatever containing matchers that we used to maintain. We removed them because they are already existing asymmetric matcher. So if you can see here, from to have elements to have text containing, you just replace that with to have text expect string containing. So those are just using the built-in functionalities instead of using our own maintained ones to make the interface more lean. We removed the JSON wire protocol commands, the DevTools and DevTools service packages. If you use them, if you use the DevTools service package, please migrate over to the Lighthouse service that essentially carries the same functionality for all Lighthouse-specific things. And if you have been using the DevTools service to interact with the DevTools protocol, then we recommend to use, the getPuppeteer command.
I love this so much. And y'all on the live stream and who's watching the recording, I love this human so much, and he's given back so much to the open source community. We're going to continue to get questions coming in online, y'all, and we're going to announce them tomorrow. So while we prefer that y'all get your questions in via the LinkedIn live event, if you got other questions, we got them for you. This is a community. It's open source. That said, we do want to make sure we wrap this recording. I'm a stage mom, but I'm also in marketing. So we're going to wrap this live stream soon. As we wrap, friend, we're going to continue this conversation offline. As we wrap, what advice would you give to anyone who has wanted to contribute to this project, but questioned their time, questioned the value? Like, what advice would you give?
I would say don't see it too complicated. Like often the small improvements can be a best start. So if you don't know what kind of work you can do on the project, or if you don't know where to start, just join our Discord channel and we can help you out there. And then there's so many little things that people can take on to start growing expertise and experience working with the project. And furthermore, the maintainers are there to help, find the right task for the right person. And there's really a task for everyone there. So that won't be a difficult thing.
I love that so much. And we have one last question coming in through the chat from Deep Barot, CEO. Will it support Flutter apps?
It does. WebdriverIO supports the WebDriver protocol, and hence Appium supports the WebDriver protocol. And so you can use WebdriverIO with Appium to automate Flutter apps these days.
Woo. Shout out to JLibs. We love you. With that said, y'all, we're going to wrap up this recording. We love you all so much. Thank you to everyone who tuned in live, who's watching this recording, and an afterthought. And we hope that this gets you inspired for open source. I love this stuff on so much. And I hope that you all get inspired to contribute and get involved. Make a note that we will be announcing our raffle prize winners for some swag and amazing merch tomorrow. So continue to drop your conversations and stay engaged in the conversation. With that said, we love you all so much. Have a blessed morning, evening, wherever you are. Continue contributing to open source. We love you. Mwah.
Thank you for watching.
Ciao, y'all.